Alright, we are now on to 12-3, in which we are going to be talking about central angles and arcs. And so hopefully by doing this you can say that I can find the central angle of a circle, which will be one of your proficiencies. So just keep that in mind as we're going through. I'll mention kind of what the proficiency is going to look like as we are actually going through the lesson right now. Just a couple definitions to get down, just to kind of talk about, because again, this entire chapter is all about circles. So a semicircle, as you probably would know already, is half of a circle. But just know that the minor arc of a circle, so what we're going to be doing is we're going to be splitting arcs up into splitting our circle up into from line segments, as you can see down on the bottom here. This one here is a semicircle because it splits it in half. And then if I take my radii of my circle and do not have them completely across the circle but kind of bring one towards it, I'm going to have a minor arc, which would be less than a semicircle, and a major arc, which is going to be greater than. So if you could get those definitions down. Another thing to just keep in mind as we're going through our lesson is talking about what's called a reflex angle, which is an angle whose measure is more than 180 degrees. So again, sometimes they call it a major arc, sometimes they call it the reflex angle. The smaller one is then also called the acute, and then you have the reflex on the outside of that. I remember back to chapter 2 or 3 that when we were talking about arcs, in which we basically were only talking about the smaller than 180 degrees, we're going to be expanding out a little bit more as we go along in this chapter. The one thing that, again, as we already mentioned before, the central angle of a circle is an angle whose vertex is the center of the circle. And so we have C is our center of our circle, and as we go out, we have our minor arc, we have our major arc, but there is a central angle here from A to B, which makes up the minor arc, and technically there is an angle, the reflex or the major arc angle here, which makes up A all the way to through D all the way to B. So we would call this angle here AB, but we would call, if we were talking about the major arc, we put a second point on the outside of it, and we would call this arc ADB. So that then we're continuing around all the way around. So that is the central angle. So again, it has to be from the middle. Later on, we're going to be pulling that basically out of the center, and it's going to get a little bit more complicated. But when it's in the center, we call it that center angle, and it's fairly straightforward. That this would be something to get down, just because it will be our proficiency, and this may seem like one of the easiest proficiencies we will ever have in this class. But it confuses people just because we're learning a lot of different definitions. The measure of a central angle is equal to the measure of its intercepted arc. And so if this angle here, APB, is equal to 50, the angle itself, the measure of AB, is also 50. And so on the proficiency, it's going to ask you, okay, the angle is equal to 50, what's the arc equal to? Or if the arc is equal to, say, for example, 120, it would be asking for the angle, which the answer would then, of course, be, again, 120. So just be able to keep that in mind, and just know that, just recognize that this is the easier question of the proficiency itself. The arc addition postulate. If C is on AB, then I know that the measure of AC plus the measure of CB is equal to the entire arc ACB. That there is kind of based off of, again, if you think back to the ruler postulate, which is said that the like AC plus CB would be equal to AB. On a ruler, remember, or the angle postulate, which talked about the angle version of it. This is just now the arc postulate. So the smaller two arcs added together will then just equal the bigger arc there. Keep that in mind as we're going through, especially with our proofs. So that angle there plus that angle there is equal to the entire one. A theorem: in a circle, equal chords have equal arcs. And so what that means is if I know that AB is equal to DC, so the length of AB plus the length of D, and I know C is getting cut off here on the video, but this is D all the way down to C. If I know that those two lengths are equal to each other, then I would know that angle 1 is equal to angle 2. Now vice versa, in a circle, if I have equal arcs, I have equal chords, so meaning if angle 1 is equal to angle 2, then I'm able to conclude that AB is equal to DC. Chords, again, are the, if I have a circle and I have 2 points on it, just drawing a straight line across that would give me my chord. It could be the diameter, but it does not have to be. It's just any 2 points. If I draw a line straight across and it's cutting that circle, it is considered a chord. Our first proof that I want you to go through, so take note again of the written directions. Kind of vertical angles, angle AOB and angle COD are central angles of both circles. So with that said, even if it doesn't look like it, it's fairly close. I tried to make it as close as I could, but we're going to say that O, I know these are central angles, so I know that O is the center of my circle. I know that these are vertical angles, and so what do I know about vertical angles if I'm going to try to prove that measure of AB is equal to measure of CD? So just kind of keeping those things in mind as we're going through. But again, I want you to prove that measure of AB is equal to measure of CD. So we're going to do that actually now together, just with some practice. So let's start off with what we know. We know that angle AOB is equal to angle COD. Well, why do we know that? Well, based on our description before, we know that vertical angles are equal. That hopefully was pretty straightforward. Now it kind of gets a little bit more complicated, is because, okay, so I have these angles. I want to prove that arc AB is equal to arc CD. So I'm trying to take these angles that I have, and I'm going to have to try to convert them into arcs here. Well, using the prior definitions that I had, angle AOB, I know that that arc is equal to the arc of my of just AB itself. I know that the measure of my angle is equal to the arc across, which then consequently with angle COD, I can kind of conclude the same exact thing. If I know the angle here is equal to the arc itself as well, based off of the fact that the measure of the central angle, knowing that they're center angles, is equal to the measure of its intercepted arc. Meaning these angles are crossing those points right there, and so I'm able to conclude that those angles are equal to those appropriate arcs. Now based off of that and looking at our angle 1, I can then take out AOB and replace it with the measure of AB, and I can take out the measure of COD and replace it with the measure of CD. And what did I do there? Well, I substituted, thus concluding my proof that actually the measure of AB is equal to the measure of CD. Now remember, even though they don't necessarily look equal to each other, we're dealing with degrees here. We're not dealing with length, and so these arcs right here are the same degree measurement as we go through. Lastly, I want you to try this proof on your own and bring kind of your answers, your statements and your reasons to class tomorrow, and we're going to talk about them before we get there. But points A, B, C, and D and E lie on a circle, and I know that AB is equal to DE. I would like you to prove to me that based off of that information up there, I would like you to prove that AD is equal to BE. I'll start you off with the first step. Hopefully, of course, you're able to think right away that it's okay, I should always start with my givens. And so again, yes, I want you to prove it with our scary guy right here. I would like you to prove it. I'm going to start with my AB is equal to DE, and I know that that is given. And so kind of a hint for you on that is here's my chord that I have AB is equal to my chord here, DE. What theorem did we use prior to that to maybe base some things off of that? Also think about the fact that I have AD. So I have an arc here of A all the way to D. And so noticing that I'm basically also including B in that arc. Okay. Using a postulate that we previously talked about in this chapter, using that postulate and BE. So I have from B to E, knowing that I'm also going through D at that point. There is another kind of example of an idea in which we should use a postulate that we talked about already today. So I'm going to leave you with this. I want you to try this proof and come to class tomorrow prepared to discuss it and collaborate with the class. So thank you for listening. Try this proof, and we will see you next time.